How do you solve a system by graphing? Well, we're going to go ahead and discuss what a system is, and then I'm going to show you how to solve it by graphing. This is for task 1.7, so make sure this is a title that goes at the top of your paper, and make sure you give the title for the task right afterwards, okay? And then this is the video title that goes in the left-hand column. Okay, nice reminder of what your video notes look like. These are notes, how they should be set up. Make sure your notes look this way once you are completed. Here is example number 1. And let's begin. We're going to solve this system by graphing, and then we can check our answer. So, first of all, a system is a set of 2 or more equations. So notice that we have one equation here, and since we have 2 equations, remember it has to be 2 or more, this is our system of equations, and is notated by a curly bracket. You'll usually see the curly bracket around the 2 equations, so you know that they're a system. It's like they're a family or unit. They belong together, and they're a system of equations. So that means that I need to find a solution that will work for both equations since they're in the same exact system. To do that, we need to find out what point on the graph would correspond for x and for y and would solve both equations. Now, we could do this algebraically using math, but we're going to hold off on that. Instead, we're going to solve it by graphing because we know how to graph. So I'm going to go ahead and do the first equation with the black, and then I'll do the second one with red. Let's go ahead and begin. The graph, we start at -1 on the y-axis, and then we're going to go, we're going to go down 1, 2, and over 1. We can even do another point, down 1, 2, and over 1. And here is our line. And now let's go ahead and graph the second line, y equals x plus 5. We start at 5 on the y-axis, and then we go up 1, over 1, up 1, over 1. And here is our second line. Now that we graphed the 2 lines, the point of intersection is what the solution is. And so this is our point of intersection right here. And notice that we're getting some half. We're kind of like in the middle. I see that we're near the 1, 2, 3. We're near the 3 for x, or excuse me, 3 for y. So if I had a point, I'm near the 3 for y. And for x, I'm in between -2 and -3. So let's first guess with the -2. Now to see if this is a solution, we're going to plug in -2 for x and +3 for y and check to see if we get that. So the first one, which is the black equation, I'll check. I get 3 equals -2 times -2 minus 1. All I did was take 3 and plug it in for y here, and I took -2 for x and plugged that in there. So does 3 equal -4, or excuse me, +4 minus 1? Check. Yes, it does, right? I get 3 equals 3. Now let's double check with the red line. I'm going to plug in -2, -3, so -2 goes in for x, and -3 goes, or +3 goes in for y. So 3 equals -2 plus 5. That also works. 3 equals 3. So that checks off. Therefore, this point is a solution to the system of equations. Let's practice a second example. Okay, here is example 2. We are going to solve the system by graphing and check our answer. Here is our system of equations, but notice that the first equation is not ready to be graphed. So I'm going to go ahead and divide both sides by 2. That way this 2 goes away and I have x equals 2. And now I'm ready to graph. So I'll do the first line in black, and then the second line I'll graph in red. And remember, they're systems, so I'm trying to find the point of intersection of these 2. For x equals 2, I go to 2 on the x-axis, which is right here. And there's no slope or anything to calculate. So I just draw a line, and it's a vertical line at x equals 2. Okay, now let me go ahead and graph y equals -3. I go to -3 on the y-axis, which is right here. And then I draw a line through that point. And that is my line for y equals -3, which is a horizontal line. And now the solution is the point of their intersection, which is right there. Notice that it is very easy to see, easier than the last example. So the point for intersection for this equation is going to be positive 2 and negative 3. Positive 2 and negative 3. So let's see if we're correct. We'll take 2, plug in it for x here. Does 2 equal 2? Check. Yes, it does. Then I'll take negative 3 and plug it in for y here. Does negative 3 equal negative 3? Check. Yes, it does. Therefore, this is the point of intersection and the solution to my system of equations. Notice that in order for me to find that point, I had to graph. I want to remind you that if this video was challenging, to rewatch the video and follow along with your notes. Whatever questions you have, bring those to class and we'll practice on solving the system by graphing. This is the first time I'm doing this year, so for those of you doing your notes, keep up the good work. I'm really proud of you. But here's your opportunity for extra credit. I want you to go ahead and at the top of one task, 1.7 notes, that was for this video and the previous video, I want you to write down the word, the word computer. If you write down the word computer and hand me your notes, I will give you 10 extra credit points. 10 extra credit points for writing the word computer at the top of your notes and handing those in to me when you come to class tomorrow. It will be really funny to see other students that don't know what's going on, but you're going to hand it in with the word computer at top, and I'm going to give you 10 extra credit points. And maybe a piece of candy. All right, I'll see you in class.